So, for today's lecture, we'll be doing section 4.4 of our manual, and the title is Quadratic Functions. So we will define what a quadratic function is, and we will look at some properties of the quadratic functions, and then we will answer some standard problems involving quadratic functions, as well as some applications to word problems. Okay, so first, a quadratic function in the variable x. So this is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers with a not equal to 0. So this condition here, a not equal to 0, is important, because if your a equals 0, then this ax squared term will not be present, and therefore the function will just be a linear function. Okay, so the condition that a not equal to 0 here is important for us to be able to define the quadratic function. Okay, the domain of this quadratic function is the set of all real numbers, because, well, if you replace x with any real numbers or with any real number, you have ax squared plus bx plus c will just be another real number. So this function ax squared plus bx plus c is defined at every real number. Okay? Therefore, the domain is the set of real numbers. Okay? Now, here are some remarks with regards to the function, the quadratic function ax squared plus bx plus c. The graph of a quadratic function is called a parabola. Okay? So it's called a parabola. In the linear function, the graph is a line. Okay? For the quadratic function, we'll get a parabola. So if the a, the coefficient of x squared, okay, which is a in here, if a is greater than 0, the parabola opens upwards. If a is less than 0, the parabola opens downwards. Okay? So this is an example of a quadratic function and its graph. Okay? So we have the function f of x equals x squared. So here you see the coefficient of x squared, it's 1. Okay? And 1 is a positive number. So this is a parabola and it opens upwards. Okay? And then this is an example of the other case. So we have a function f of x equals negative x squared. The graph is a parabola. The coefficient of x squared, it's negative 1. So it's a negative number, so the parabola opens downwards. Okay? Furthermore, the larger the value, of absolute value of a, the narrower the opening of the parabola is. Okay? So if the absolute value of a is actually greater than 1, okay, and as it becomes larger, okay, the graph or the opening becomes narrower. Okay? And if the absolute value of a becomes smaller, okay, then the wider the opening of the parabola is. So for example, we look at this red here, this dashed graph of the parabola. It's the parabola f of x equals x squared. Now we have the purple parabola here. We have f of x equals 2x squared. Okay? So 2 is greater than 1. This is the graph of f of x equals x squared. The graph of f of x equals 2x squared is narrower compared to the graph of f of x equals x squared. And then here we have the blue graph, f of x equals 1/4 x squared. So 1/4, it's less than 1, okay? So this is the graph again of f of x equals x squared. But for the absolute value of a here, it's 1/4, okay? It's now less than the absolute value of a here, or this guy here, and it's wider, okay? The graph is wider compared to the two guys in here, okay? So the larger the value of the absolute value of a, the narrower the opening of the parabola is. The smaller the value of absolute value of a, the wider the opening of the parabola is. Okay? Question so far? Now, let us consider the function f of x equals ax squared plus bx plus c, where a is not equal to 0. So let us look at some more properties of this function. If a is greater than 0, the parabola, which is just the graph of the function f, has a lowest point. Okay? Take note that if a is greater than 0, the parabola opens upwards. Okay? And therefore, it has a lowest point. If a is less than 0, okay, the parabola has a highest point. Because if a is less than 0, the parabola is opening downwards. Okay? So a positive, it has a lowest point. A negative, it has a highest point. The highest point or the lowest point of the parabola or f of a parabola is called the vertex of the parabola. Okay? So the highest point or the lowest point of the parabola is called the vertex of the parabola. Now, the vertical line passing through the vertex of the parabola is called its axis of symmetry. Okay? This means that the parabola is symmetric with respect to this axis. Okay? So whatever you see on the left, if you fold the plane along this axis of symmetry, the graphs will just overlap. Okay? So for example, we have here your function f of x equals x squared. So this is the parabola. So a is positive in here. Okay? So it has a lowest point. This is that lowest point. Okay? This is that lowest point. And then the axis of symmetry is the line passing through the vertex. So the vertical line passing through the vertex. So this is the vertical line passing through the vertex. Okay? So happened that this is the y-axis. But if you fold the plane, okay, if you fold the plane along this y-axis, then this guy here will just overlap this graph here. So that's why it's the axis of symmetry. Or it is said that the parabola is symmetric with respect to this line. Okay? So a greater than 0, a here it's 1, we have a lowest point. If a is less than 0, in here, you have f of x equals negative x squared. So a here, it's negative 1. So again, it opens downwards because a is negative. But in this remark, it has the highest point here. Okay? So this is the highest point here. Okay? And just like before, the axis of symmetry, it's just the y-axis. In this case. Okay? So we have here the axis of symmetry. Question so far? Next, by applying the method of completing the square, the quadratic function f of x equals ax squared plus bx plus c, where a is not equal to 0, so we still have that function. It can be written in the form f of x equals ax minus h squared plus k. Here, your h, this h here, it's negative b over 2a. And the k here, it's 4ac minus b squared over 4a. Okay? Or simply, it's just the evaluation of your function f at h, but here your h is negative b over 2a. So take note, if you take x equals h, then this becomes h minus h. So it becomes 0. So you will just have f of h equals k. So it's just the evaluation. K is just the evaluation of the function f at that value h, which is negative b over 2a. So every quadratic function, you can write it in this form. So you will be able to determine immediately the vertex, okay? Because that guy, the ordered pair h comma k, this h and k here, okay, this point here is the vertex of the parabola. Therefore, if you are given a function, a quadratic function, and you were asked to find the vertex of the graph of that quadratic function, then you just have to compute for this. Okay? And you will be able to get the vertex of the parabola. Okay? And of course, the vertical line passing through this vertex, since it's a vertical line, it's just x equals the value of h. But your h here, it's negative b over 2a. So the vertical line, x equals negative b over 2a, it's the axis of symmetry of the parabola. Okay? It's the axis of symmetry of the parabola. So if you look at this is a graph of some parabola with this equation. F of x equals ax squared plus bx plus c, which can also be written as a times x minus h squared plus k. So this is the graph. So we assume that in here your a is positive because this is opening upwards. Okay? So here is the lowest point. So it's the vertex, h comma k. And the line passing through that vertex, particularly the vertical line passing through that vertex, it's just your x equals h, but your h, again, it's negative b over 2a. Okay? Questions so far? Now, again, let f of x be the quadratic function ax squared plus bx plus c, where a is not equal to 0. We compute what we call the discriminant of this function f, or of this quadratic expression here. The discriminant is calculated in this way, b squared minus 4ac. Okay? So discriminant, it's b squared minus 4ac. So if the discriminant is positive, okay, the graph of f has two distinct x-intercepts. Okay? So this means the parabola crosses the x-axis twice. Okay? So if you look at this graph here, this is your y-axis, this is your x-axis, and this is your parabola. Okay? With b squared minus 4ac greater than 0. So the graph of the parabola crosses the x-axis twice. Okay? So here and here. Okay? Of course, this one here, your A is assumed to be positive because this opens upwards. If A is negative, it's the same. Okay? You'll just compute for b squared minus 4ac, and if it is positive, even if it opens downwards, okay, as long as the discriminant is positive, it will intersect the x-axis twice at those points. Okay? So later we will see how to get these points of intersection when we solve some examples. Okay? Now, if the discriminant b squared minus 4ac equals 0, okay, the graph of f has exactly one x-intercept. Okay? So this means the parabola touches the x-axis at its vertex. Okay? Take note of the word touches. The other one, it says crosses. Okay? Here, the parabola only touches the x-axis at its vertex. So for example, in here, so this is the case where b squared minus 4ac equals 0. So this is the parabola, this is your y-axis, this is your x-axis, and that's the vertex. Okay? So the parabola only touches the x-axis. Okay? It also means that the parabola, the graph of the parabola, or the graph of the quadratic function intersects the x-axis just once. Okay? Unlike in this case, okay, when the discriminant is greater than 0, the graph of the quadratic function intersects the x-axis twice. Okay? And finally, if the discriminant b squared minus 4ac is less than 0, the graph of f has no x-intercepts. This means the parabola does not cross nor touch the x-axis. Okay? Graphically, we can see it this way. Okay? So this is the graph of the parabola. This is your x-axis. So if A is positive, the parabola opens upwards. And when your b squared minus 4ac is less than 0, okay, the parabola is completely above the x-axis. Okay? If your A is negative, and you have the case b squared minus 4ac less than 0, the parabola, the graph of the parabola is completely below the x-axis. Because again, your A is negative, it opens downwards. Okay? So what I'm saying is if your A is negative, it can be something like this. So this could be the graph of some function f of x equals ax squared plus bx plus c with a less than 0. And of course, we assume b squared minus 4ac less than 0. So the graph is completely below the x-axis. Okay? Question? So when you have a quadratic function, okay, what are the special objects associated to this quadratic function? First, of course, the opening or the graph of the parabola itself. Okay, the graph of the parabola. Okay, so either it's opening upwards or downwards. Okay, and that depends on the coefficient A. If A is negative, you have opening downwards. If A is positive, you have opening upwards. Okay? Another important part or another important things that we need to know from the quadratic function, the vertex, okay, and the axis of symmetry. The vertex can be calculated using this formula. H equals negative b over 2a, and k equals 4ac minus b squared over 4a. And therefore, this guy here, f of x equals ax squared plus bx plus c, can be rewritten as f of x equals a times x minus h squared plus k. And that ordered pair h comma k, it's the vertex. And the line, the vertical line, x equals negative b over 2a, it is the axis of symmetry of the parabola. Okay? So here is some parabola. This is the vertex, and you have the axis of symmetry. Okay? So question so far. Okay? Let us look at this. Let us sketch the graph of f of x equals x squared plus 2x plus 2. Okay? So in here, we have your a equals 1. That's the coefficient of x squared. Your b equals 2. Okay? And your c, that's also equal to 2. Okay? So a is positive. You expect that the graph of this opens upwards. Okay? So let's find the vertex of this. To find the vertex, we need h. Okay? According to this slide here, h is negative b over 2a. So h is equal to negative b over 2a. So we have negative b over 2a. So we have negative b, it's 2 here, all over 2 times a. A here it's 1. So 2 times 1. So if you simplify this, this is just negative 1. And then your k, you can use this formula in here, 4ac minus b squared over 4a. But this one, it's hard to memorize. Okay? So what you can do is to do this. Once you have obtained your h, just evaluate the function f at h. Okay? So in here, your k, it's simply f of h, or your h, you have obtained that one to be negative 1. So this is just f of negative 1. So if we replace our x with negative 1, we will have negative 1 squared plus 2 times negative 1 plus 2. And this is equal to positive 1. Okay? This is just positive 1, which means that the vertex here, h, comma k, this is negative 1, comma 1. Okay? Let's Because of this, because you already now have the vertex, okay, you can now write the axis of symmetry. The axis of symmetry, it is the line, the vertical line, x equals h, which is just -1. Okay? And since now your a, it's greater than 0. So in here, your a equals 1, which is greater than 0. The parabola opens upwards. Parabola opens upwards. Okay? Therefore, we can now have we can now have the graph of the function f based on these guys in here. So we will have, suppose this is your Cartesian plane. This is your x-axis. This is your y-axis. Then the axis of symmetry, x equals -1. So suppose this is your -1. Okay, you have your -2 here. You have -3. This is your 0. This is +1, +2. This is +1 for the y, +2 for the y, +3 for the y, etc. The axis of symmetry, x equals -1. So we have this. So the axis of symmetry is the vertical line. Okay, the vertical line passing through that, the vertical line with x equals -1. That's the x coordinate of your vertex h. Okay, so this is your x equals -1. The vertex, it's -1, 1. So it's somewhere here. This is your x equals -1. This is your y equals 1. So the vertex will be somewhere here. Okay? Now, in order to continue the graph, what we're going to do is to get two other points. One on the left of the axis of symmetry and another on the right of the axis of symmetry. So on the left of the axis of symmetry, we choose x to be less than -1. So maybe -2, -3, it's up to you. Let's say when x equals -2, okay? When x equals -2, you have f of -2. This is -2 squared plus 2 times -2 plus 2. So if you calculate this, -2 squared, that's +4, plus 2 times -2, that's -4 here. So 4 minus 4, that becomes 0. And then you have the plus 2 there. So you have the 2. So you have -2 comma 2. So -2 comma 2, it's somewhere here. Okay. So this is x equals -2. This is y equals +2. And then another x. Here you have x. So when x equals 0, when x equals 0, you have f of 0. This is just 0 squared plus 2 times 0 plus 2. And this is again +2. So when x equals 0, you have this, y equals 2. So you have this. So once you have those two points, just draw a parabola passing through these two other points. Of course, the lowest point will be the vertex because, again, your a, it's equal to 1, which is a positive number. parabola opens upwards. Okay, so vertex is lowest point. So you can just sketch it, something like this. So this is the left side, or this is the right side, and then this is the left side. Okay, so this will be a sketch of the graph of the parabola. Okay, so this is your f of x equals x squared plus 2x plus 2. Okay, so we have the sketch. We did not compute for the discriminant, but anyway, let us try to compute what the discriminant is. And you will see that our discriminant will be negative. Okay? Why is it negative? Notice, according to our graph, the graph does not touch the x-axis nor crosses it, which means the discriminant must be negative. Indeed, if we calculate for the discriminant, we have b squared minus 4ac. So this is equal to b squared, that's 2 squared, minus 4 times a, it's 1, times c equals 2. So this is equal to 4 minus 8. And this is equal to negative 4. And indeed, it's less than 0. Okay? Questions? Questions? For our next example, analyze the quadratic function f of x and analyze the quadratic function f of x by giving some properties of its graph. So we want the vertex, we want the opening, we want the axis of symmetry. Okay, those are the three important properties for the graph. And then we will have some two other points aside from the vertex in order to sketch the graph of this function here. Okay, so here we see a, it is equal to -1. So this is less than 0. Your b here, it's -6. And your c here, you don't see any constant. So this is equal to 0. Because a, it's negative, this means that parabola opens downwards. Okay? Okay? Now, let's compute for the vertex. Vertex h comma k. So h, please remember, it's -b over 2a. So this is equal to negative of -6 divided by 2 times -1. So negative, it's positive. On the denominator, you have positive times negative. So denominator is negative. So you will get here 6 over -2, and that's equal to -3. Okay? And then you have your k. This is f of h, which is -3 now. And this guy here, we have negative of negative 3 squared minus 6 times negative 3. So this guy here, it's negative. Negative 3 squared, that's 9. So negative 9. Here you have negative 6 times negative 3. That's positive 18. So plus 18. And this is equal to positive 9. Which means you have the vertex. Vertex negative 3, comma, positive 9. Okay? And then let's have the axis of symmetry. Axis of symmetry. This is just the vertical line. X equals the h. But h is negative 3. So we now have a parabola that opens downwards with vertex negative 3, comma 9. Okay? Let's calculate the discriminant. The discriminant is, again, your b squared minus 4ac. So discriminant So b squared minus 4ac, but this is simply negative 6 squared. Correct? Negative c squared minus 4 times negative 1 times 0. So this is just 36, and this is greater than 0. So this means the parabola opens downwards, and the graph, since the discriminant is positive, the graph crosses the x-axis twice. Okay? So if it crosses the x-axis twice, let us calculate, okay, the value of x for which the parabola or the x-intercept. Okay? Since the discriminant is positive, the graph crosses the x-axis twice. So let's calculate the x-intercept. So this guy here implies parabola crosses the x-axis twice. Okay? So solving for the x-intercept, solving for x-intercept. So all we need to do is to solve this equation, f of x equals 0. Or you have negative x squared minus 6x equals 0. So you solve this quadratic equation, you factor out negative x, you will have x plus 6 equals 0. And this means you have x equals 0 or x plus 6 equals 0. So you have here x equals 0 or x equals negative 6. Okay? So far, so good. So, the parabola intersects the x-axis x-axis at the points 0, 0, and at the point 0, negative 6, 0. So in here, we have the vertex and we have two other points on the parabola. So we can use this vertex and these two other points for us to be able to sketch the graph of this function. Okay? So let's graph that. So suppose you have this Cartesian plane. Okay? And then let's have here positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's label this. You have 10 here. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And then based on the information that we have, we need x equals negative 3, we need 0, and also negative 6. So we draw or we label those points. So we need the negative values for x. So say this is negative 1, negative 2, negative 3. So this is your negative 3. Then you have negative 4, negative 5, and negative 6. So this is your negative 6 here. The vertex, according to our calculation, it's negative 3, 9. Negative 3, 9. So in here, we have the negative 3 here, we have the positive 9 here. So we will get this point here as our vertex. Okay? And then the other points that we will use are the intersection at the x-axis. And we got two of them. And of course, if we try to sketch the axis of symmetry, it's somewhat or somewhere here. Okay, that's your x equals negative 3. So we have this point, the vertex. We now have the other 2 points on the parabola, so we can now draw the parabola. So you will get something like this. Okay, and then the other one, it's also something like this. Okay, so this is your parabola. This is your f of x equals negative x squared minus 6x. Okay? Question? Now, some students do this. They have the vertex, they have the other point. When they're sketching the graph of a parabola, they use ruler and they connect these 2 points. If you do that, what you will get is a straight line from this point to this point because you used ruler. Parabola, it's not a straight line. It's somewhat curvy. Okay? It's somewhat curvy. Similarly for this. On the other side. Okay? If you look at this, here, you cannot see any straight lines on this parabola. Okay? So it is somewhat curvy there, particularly from this point to other points on the parabola. Okay? It has curve. So if you draw a parabola and you just connected 2 points, you will get some deductions because that's the sketch of the line. That's the drawing for a line. If you just connect the 2 points using straight edge. Okay? You can do that if you are asked to sketch the graph of a linear function. But if you are asked to find or to sketch the graph of a quadratic function, just give justice to the quadratic function. Okay? Questions? Next problem here, analyze the quadratic function f of x equals 3x squared plus 6x plus 2 by giving some properties of its graph. So just like in the previous example, we start with a, which is equal to positive 3. And again, this is greater than 0. So this means that the parabola opens upwards. And then b, this is equal to 6. C equals 2. Okay? And then we look for the vertex. So we have to solve for h and the k. H will be negative b. So that's negative 6 all over 2a. 2 times 3. And this is just negative 1. Okay? And then, of course, the k, it's just f of negative 1. And we will have 3 times negative 1 squared plus 6 times negative 1 plus 2. So this is just 3 minus 6 plus 2. This is equal to negative 1. So vertex is at negative 1 comma negative 1. And also axis of symmetry, it's the x coordinate of your vertex. Okay? So this is just x equals negative 1. Now let's solve for the discriminant. For the discriminant, we have b squared minus 4ac. So in here we have 6 squared minus 4 times a. What is a? That's positive 3. C, it's positive 2. So 6 squared, that's 36 minus 4 times 3, that's 12 times 2, that's 24. This is equal to 12 greater than 0. Okay? Which means that this function or the graph of the parabola should intersect or should cross the x-axis. So A, it's positive. Parabola opens upwards. The vertex is at negative 1 comma negative 1. Particularly, the y-coordinate of the vertex, it's negative 1. It's below the x-axis. But A is positive. So opening upwards, it really will cross the x-axis twice. So our computations here are consistent. Okay? And so let's solve for the x-intercept. So for the x-intercepts, it only means you need to solve the equation f of x equals 0. Okay? So you will have 3x squared plus 6x plus 2 equals 0. You can factor this. You can complete the square. Okay? I think let's complete the square. Let's complete the square. So how do we do that? But you can do factoring. Okay, you can do factoring. What I'm going to do is to complete the square here. So what I'm going to do is to add 1 on both sides of the equation. So plus 1 here, plus 1 here. So the left-hand side will have 3x squared plus 6x plus 3 equals now, right-hand side it's 1. We can factor out x. Oh, sorry, we can factor out 3. If we do that, we will have 3 times x squared plus 2x plus 1. And this is equal to 1. And then let's just divide the equation, or we just divide both sides of the equation by 3. And then this guy here, I hope you realize that this is x squared plus 2x plus 1. And this is just equal to x plus 1 squared. So you will have x plus 1, x plus 1 quantity squared. And this is equal to 1 over 3. Which means your x plus 1 is equal to 1 over square root of 3 plus and minus. Okay? Or this guy here, it's square root of 3 over 3. Okay? And therefore, your x will be negative 1. Sorry, this is still plus or minus here. So negative 1 plus or minus square root of 3 over 3. Or simply, this is negative 3 plus or minus square root of 3 all over 3. Take note that if you use your quadratic formula here, this is what you will get also. Yeah, why didn't I use the quadratic formula? It's easier. But anyway, you should be able to get this one. Okay, even if you used your quadratic formula. Okay? Therefore, at these points, okay, at these points, you will see, or you will have the intersections at the x-axis with x coordinates given by these two guys here. Let us just approximate the value of this. Okay, let us approximate the value of that. So how do we get that one? You have cube root, or sorry, square root of 3 divided by 3, okay, minus 1. So this is roughly 0.4265, or you have negative 1.57735. Okay? So these are the approximate values of the x coordinates for the x-intercepts. Okay? Then let's sketch it. So again, we have this Cartesian plane. This is your x. This is your y. Let's have here negative 1, negative 2, negative 3 in here. Then here you have positive 1, positive 2, positive 3. And then below here, you have, so you have here negative 1, negative 2, etc. Okay? And the vertex, according to our calculation, it's negative 1 comma negative 1. So negative 1 comma negative 1. So it's at this point here. Okay. And then the other 2 points, that we got, we have at x almost negative, almost 0.422. And then the other guy, it's negative 1.577. So negative 1.577, let's just approximate it. So negative 1.577. Where is that? I think that's not correct. I think in my computation, it doesn't look right. So in here, and then in here, it doesn't look right relative to the vertex. Let's get the computation again. Let me look at this again. So let's see. I now have square root of 3 divided by 3, and then you have that minus, and then minus 1. Yeah, this guy here, it's correct. And then the other guy, whoa, it's both correct. Negative 4226. Oh, that's right. This guy here, it's negative. Okay, I forgot to put the negative there. So this guy here, it's negative 0.42265. So you have the negative. Okay? So now it's more correct. So negative 4 or negative 0.422 something. 0.5 is somewhere here, you see. So negative or 0.4, it will be somewhere here. So negative 0.5, this is that point. So negative 0.4, it's somewhere here. Okay? So let us put that. So it's somewhere here. And then negative 1.5, it's somewhere in the middle here. And then 0.57 or negative 1.57, it's somewhere here again. Okay? Which means we put our dot there. Okay? And therefore, we can now start sketching the graph. Okay? On this side, we have something like this. Okay? On the other side, we have something like, of course, something like this. Okay? Now, what we're going to do is to extend the graph. Let us calculate the y-intercept. The y-intercept is obtained by setting x equals 0. Okay? Let's add that point. Calculating or solving for the y-intercept. Solving for y-intercept. It means we just need f of 0. But f of 0, it's just equal to 2. Which means the point 0, 2 is also on the graph of the parabola. So this point here is still on the parabola. So if we extend this graph, it will be something like this. Okay? And of course, you can just extend this here. Okay? Oops. Okay? So this will be roughly the sketch of the parabola. Okay? Questions? So now, we have here the y-intercept. You can also solve for the y-intercept for this guy here. But the y-intercept, it's part, it's when your x equals 0, and we have calculated that already here. Okay? For this guy also, we solved for the y-intercept indirectly. It happened when x equals 0 in here. Okay? So y-intercepts are calculated also. Okay? Questions? So, as usual, the problems that we'll be asking you are not really always like this. So they will be given or interpreted via word problems. So let us work on some word problems here. So we do quadratic models. Okay? So it's a word problem wherein when we translate the word problem to mathematical interpretation, or we interpret the word problem mathematically, we will be able to get some quadratic functions or equations. So quadratic models. So let us look at this particular problem, which I got from this book. Okay. The granny shots. So the last player in the NBA to use an underhand foul shot, or called a granny shot, okay, was Rick Barry, okay, who retired in 1980. So he's a Hall of Famer. Okay, if you're interested or if you're watching NBA or whatsoever, I think you know Rick Barry. Okay, Barry believes that the current NBA players could increase their free throw percentage if they were to use an underhand shot. Since underhand shots are released from a lower position, the angle of the shot must be increased. Okay? Now, if a player shoots an underhand foul shot, releasing the ball at 70-degree angle from the position, 3.5 feet above the floor, then the path of the ball can be modeled by this function here. So you have your h of x equals negative 136x squared over v squared plus 2.7x plus 3.5. Here, h is the height of the ball above the floor, x is the forward distance of the ball in the front of the foul line, and v is the initial velocity with which the ball is shot in feet per second. So if we look at this, okay, this is not a hand-to-hand shot, okay, but this is how we interpret it. So you have some ball, okay, you have some ball coming from the lower than your possibly your shoulder, so somewhat coming from here, but of course there will still be an angle, okay, there will still be an angle, and according to this problem, x is the forward distance of the ball in front of the foul line, so the distance will be from this guy here going to the center of that ring. So just the horizontal part in here, okay? And v is the initial velocity. So that's how, that's the velocity that you will use in order to throw the ball. And of course, h is the height of the ball above the floor. So meaning at certain point, okay, at certain point, this is your h, okay? When you release it, at some time your ball will be this, okay? So this is at x. So this height here, this is your h of x, okay? Okay? So, now we are given h of x equals negative 136x squared over v squared plus 2.7x plus 3.5, where h is the height of the ball above the floor, x is the forward distance of the ball in front of the foul line, and v is the initial velocity with which the ball is shot in feet per second. First problem. The center of the hoop is 10 feet above the floor and 15 feet in front of the foul line. So 15 feet from here up to here, okay? And 10 feet from here up to here. So 10 feet above the floor, 15 feet from foul line to that center, okay? Determine the initial velocity with which the ball must be shot in order for the ball to go through the loop. So we want to calculate this V. Okay, we want to calculate this V so that from this point going to that, okay, going to this center of the hoop, meaning the ball will shoot inside that ring. Okay, we want to solve for that initial velocity. Okay, so how do we do this? So in here we have h equals 10 and x equals 15. Why? Well, from this point up to this point, that's your 15, and it's the distance from the foul line. So that's your x. X equals 15. And the height, it's your 10 feet. Okay? Which means at this particular point, this is the point 15, comma 10. Correct? Following? So we have h equals 10 and x equals 15. So you will have a value for h, you will have a value for x. What's left in this equation is the variable v. Okay, which means we just substitute, plugging in the values. You have 10 equals h of 15. So the value of h at x equals 15, you have 10. But using this equation, we just plug in x equals 15 and we will have this. Correct? So we solve this right-hand side. We solve this right-hand side in here. Particularly, we solve for v. We isolate v. So you multiply both sides of the equation by v squared. So you will get 10v squared equals negative 30. So if you multiply this guy here, it's negative 30,600. If you multiply this, you will get 40.5. So multiply v squared also. And here you have 3.5 times v squared. Okay? So we have this again. So this is the function h of x at point x. And this guy here, it's your h of 15. And this is equal to 10. Okay? So now from here, we just combine all those with v squared. And yeah, this guy here has v squared, this guy here has v squared, this guy here has v squared. And you isolate that. Okay? So we will have the following. You have 34v squared equals 30,600. So you move this guy to this side. And in here you have 40.5v squared plus 3.5v squared. That's 44v squared. And then this guy here, you move to this side. So you will have 44v squared minus 10v squared. That's your 34v squared. Okay? So 34v squared equals 30,600. So we solve for v squared. We divide this by 34. Therefore, you will have v squared equals 900. And in here, your v squared, you now have your v squared in here. Okay? So you will have the exact h of x. But let's calculate for that velocity. Your v equals 30 feet per second. Okay? In fact, this has two possible values. You have either positive 30 or negative 30. But in here, believe me that this is your positive side. Okay? This is the positive side. Well, you can think of this as since your function h of x increases as x increases, then you'll get this initial velocity. Okay? If we go back to this, initial velocity is the one just right after the release in here. Okay? That's your v here. In calculus, if you are going to take calculus, you will learn that if you do this, your h increases your x also increases. This velocity must be positive. Take note, velocity, it's two-dimensional. You have the magnitude and the direction. Okay? The magnitude, it's the absolute value of v. The direction, it's either going up or going down. So this guy here, it's going up there and then going down here. At different points on this sketch here, at different points, this velocity will change. But again, at this particular point, this is your initial velocity. Okay? This is your initial velocity. So at this particular point, the ball is going up. Okay? And it's also going away from this initial position. So your velocity is the positive version. So you will know more about that when you go to your calculus. Calculus 1 positive. So just for now, believe me that it's your 30 feet per second. So that's your initial velocity. Okay? Questions so far? So here is your initial velocity. Next part, we write the function for the path of the ball using the velocity found in A. So like I said, you already have your v squared equals 900. So you just replace this v squared here by that 900. And therefore, you'll just have this. Okay? H of x equals negative 136x squared over 30 squared, that's your 900, plus 2.7x plus 3.5, and you will get this quadratic equation. So negative 34 over 225 x squared plus 2.7x plus 3.5. Okay? Next, determine the height of the ball after it has traveled 9 feet in front of the foul line. Let us look at this. So according to this is 15 feet. So 9 feet from the foul line. So if we divide this into 3 parts or into 5 parts, you have 1, so you have 3, 6, or maybe this one is 3, 6, 9, 12. So maybe it's at this point. Your x equals 9. So you want to get the height here. Okay? Okay? But to do that, we can just plug in. Correct? We can just plug in x equals 9 in this equation or in this equation. Okay? We just need to plug in x equals 9 in this equation and we will have the height. So h of 9, so you got this, you have negative 136 times 9 squared. Your v squared, that's your over 900 here. And then 2.7x times 9. So 2.7 times 9 plus 3.5. And we will have 15.56 feet. Okay? 15.56 feet. So if we look at this graph again, okay? So maybe, just maybe, this is where your x equals 9 is. X, nope, not there. Let us adjust it to somewhere here. So x equals 9, and the height would be somewhere here. And according to the calculation, it's somewhat 15.57. Is that 15.57? 56. 15.56 feet. And indeed, it should be above 10 feet. Looks like above 10 feet. Yeah? Okay? Questions so far? And then here, find additional points and graph the path of the basketball. So maybe we can use h of 0. Okay, it's 3.5. When x equals 0, you just have your 3.5 here. H equals 5, it's roughly 13.2. X equals 15, it's 10. So we have this point, we have this point, we have this point, and we can even use this point, h of 9, 15.56. And the graph will be here. So you have here 0, 3.5. In here you have 5, 13.2. In here you have 9, h of 9. I wrote it before. And in here you have your 15, 10. Of course, this part here, it's no longer, well, technically in basketball, this will now not be precise. Okay? So just at the basketball side of the problem, the graph will stop at this. Okay? The graph will stop at this. Okay? So again, let us look at these points here. So how we got them, we have this. So h of 0, that's 3.5. H of 5, that's roughly 13.2. H of 15, that's 10. Okay? So again, this is the graph. And like I mentioned, this part here, with respect to the problem, which is just basketball, this part here is not included. But anyway, your function h of x as a function itself, okay, you can continue with this going down here and here going down there. Okay? Questions for this problem? Let's have another problem here. Motion of a golf. So a golf ball is hit with an initial velocity of 130 feet per second at an inclination of 45 degrees to the horizontal. In physics, it is established that the height h of the golf ball is given by this function. H of x equals negative 32x squared over 130 squared plus x, where x is the horizontal distance that the golf ball has traveled. Okay, so very much similar to the basketball problem, except that, of course, in golf, your ball is always on the ground or will start from the ground. Okay, and notice they already gave the initial velocity, and this guy here, 130 squared, it's very much similar to your b squared before, correct? So the formula is consistent. Okay? So we are given this h of x. Okay? We want to determine the height of the golf ball after it has traveled 100 feet. Okay? So we want to determine h after the golf has traveled 100 feet. And we say it's the horizontal. Okay? Horizontal distance from the initial point of the golf towards the 100 feet. So roughly, if this is the ground, this is where the starting point of the golf ball. So it's somewhat like this. So if you have this point is your 100 feet, okay? And we are asked to find the height. So we will be looking for this point here. So this is your h at 100 feet. Okay? But it's in here. All we need to do is to substitute x equals 100 into this function. Okay? So if we do that, we have the following. With x equals 100, h of 100, this is negative 32 times 100 squared over 130 squared plus 100. So roughly, we'll get 81.065 feet. Okay? So 81.065 feet. So that will be the height of the ball. Okay? For letter B, what is the height after it has traveled 300 feet? So similar solution, all we need to do is to change x equals 300. And if we do that, we'll get 129.586 feet. Okay? Questions so far? And then, how far was the golf ball hit? So from here, let us go back to the sketch that I made. So from here, according to our calculation, this is not accurate. So maybe this is your 300 feet. Okay. Maybe this is the 300 feet here. Assuming, so this will be h of 300. And then h of 100 will be somewhere here. H of 100. Again, the scaling here, it's not accurate. So in here, you have the 100 feet. But anyway, the problem is the third problem there, okay, the third problem there. So of course, this golf ball will land somewhere here. Okay, so how far is this from the initial point? Okay, so how far is this from the initial point? But what does this mean? it means your height is equal to 0 because it's on the ground. Correct? It's on the ground. So our h is equal to 0. So in order to calculate this guy here, okay, we are asked to find the value of x when the golf ball has hit the ground. Or that is, we need to find the x such that h of x is equal to 0. So we have this equation here. You have negative 32x squared over 130 squared. And if we factor x, we will have here negative 32x over 130 squared plus 1 equals 0. So you will be able to see x equals 0 from here. That's your starting point. And then the other guy, which is this guy here, x equals 130 squared over 32, roughly 528.125 feet. That's the other end. That's where the golf ball landed. So at this point, 500 something plus. Okay? Where is that? Okay, so 528.125 feet. Okay? Questions? Next problem. Cost of transatlantic travel. So a Boeing 747 crosses the Atlantic Ocean, which is 3,000 miles, with an airspeed of 500 miles per hour. The cost, which is in dollars, per passenger is given by this equation. C of x equals 100 plus x over 10 plus 36,000 over x, where x is the ground speed, okay? It's your airspeed plus or minus wind. Okay, so take note in here, the airspeed is 500 miles. The ground speed, okay, the ground speed, it's your airspeed plus and minus the wind. So either the wind will slow you down on air, okay, on air, or it will speed you up. Okay, it adds to your airspeed, or it subtracts something from your airspeed. So that is your ground speed. Okay, so we are given that C of x. For our first problem, what is the cost when the ground speed is 480 miles per hour? Okay, and what is it if the ground speed is 600 miles per hour? So it's straightforward. The cost here, all we have to do is to substitute this x's. X equals 480 and x equals 600. So if we do that, when x equals 480, cost is roughly $223. Okay? And when x equals 600, cost is roughly $220. Okay? Questions? Next here, we want to find the domain of C. So we want to find the domain of this cost function. Okay? So to do this, one way is to write this in single fractions. Okay? You write this in single fractions. And now, since if your x represents the ground speed, the ground speed it's just positive or zero, correct? Your ground speed it's just your positive or zero. But you cannot have x equals 0 because you have a denominator here. Therefore, since x represents the ground speed, x can only be positive. Hence, you have 0 to plus infinity as the domain of C. Okay? Questions? Next problem here, let us again get some concepts from economics. So in here, we borrow revenue, okay, from economics. The revenue R is defined as the amount of money received from the sale of an item, and this is equal to the unit selling price P of the item times the number of X units actually sold. So R is equal to XP. So your X is here the number of units sold, and your P is the price per unit. And therefore, your revenue is your X times P. Take note, this is revenue. This is different from profit. Okay? Your profit, it's your revenue minus your cost. Okay? So revenue, it's just the income of selling units at a unit price. Okay? So in here, the price P in dollars and the quantity X sold of a certain product obey the demand equation given by this. P equals negative 1/3 X plus 100. Letter A, find a model that expresses the revenue R as a function of X. Okay? So in here, for letter A, the revenue according to the definition from the previous slide, revenue it's just XP. Okay? So you have X, your P here, it's negative 1/3 X plus 100. Or we can distribute the X. We will have 1/3 X squared plus 100 X. So this is your revenue function. Okay? Now, what is the domain of R? Well, technically, you can have uh, only positive or equal to 0 for the domain of R. So revenue equals 0. Okay? Revenue equals 0 if no units sold. Okay? And then from here, by the way, from here, the price cannot be negative. So you want your P to be positive, and that will contribute to the domain of R. Correct? You cannot have negative price. So you want your negative 1/3 x plus 100 to be greater than 0. So to answer letter B, okay, so we need your P to be greater than 0. The price must be positive. Or this you have 1/3 x plus 100 greater than 0. But this means your x or your negative 1/3 x will be greater than negative 100. And then if you multiply 3 on both sides of the equation, you will have x must be less than 300. Okay? Your x must be less than 300. Therefore, domain, so for letter B here, so domain of your revenue, this is just from 0, okay, to 300. Because again, if your x is greater than or equal to 300, revenue will be 0. That's fine, but you don't want that. And if your x is greater than 300, this becomes negative. Okay? Particularly, the price will be negative. And we don't give negative price. Okay? Question. Letter C. What is the revenue if 100 units are sold? So in here, we want to find R of 100. So we just have your equation is negative 1/3 times 100 squared plus 100 times 100. Okay? So we go back to that. So negative 1/3 x squared plus 100x. And that's why we have this equation. Negative 1/3 x squared, that's 100 squared, plus 100x. So 100 times 100. Okay? So if we calculate this, one way to solve this is, well, you can factor out 100 squared. You have 100 squared here. You also have 100 squared here. So you will get negative 1/3 plus 1 times 100 squared. So 100 squared, that's 10,000, correct? 10,000. And then negative 1/3 plus 1, that's 2/3. Okay? So the revenue will be 2/3 of this 10,000. So try to calculate. This is 6,666. So 6,666 point, let's round this off to 67. And this is in That's the revenue. Okay? Letter D. What's the quantity X, or what quantity X maximizes the revenue? Okay? So take note. We want the maximum revenue. If we go back to this, you have a quadratic equation and you have a negative coefficient for x squared. So the graph of this function will be opening downwards, which means the graph has a highest point. So revenue has a maximum value. Okay? So the question is, what is that value? Or what is that number of items? And then the other question is, what is that maximum value? Okay? So for letter D, again, let's just have, okay, let's have the function. Let us recall that. So negative 1/3 x squared plus 100x. So in this, your A equals negative 1/3. Your B, this is equal to 100. And of course, your C, let's just write it. It's just 0. So what quantity X maximizes the revenue? Okay. So revenue is maximized. Revenue is maximized at the value h in your vertex hk. And therefore, it will be at x equals negative b over 2a. So negative b, that becomes negative 100 in the numerator. And then 2a, so 2 times negative 1/3, correct? So this will be what? 300 over 2. 300 over 2. And this is equal to 150. Okay? So this revenue here will be maximized if you sold 150 units. So revenue is maxed. Revenue is maxed if 150 units are sold. Okay? Questions? And then, what is that maximum revenue? We just replace x with 150. Okay? So the maximum revenue is, the max revenue is you have R of 150. This is equal to negative 1/3 150 squared plus 100 times 150. Okay? So try to calculate this revenue and we'll get what? So let's solve that. So 150 squared, 150 squared divided by 3, that's negative, plus 15000, we'll get 7,500. Okay? So we'll get $7,500. 7,500. So 7,500. That will be the maximum revenue. Okay? And then, for the last problem here, what price should the company charge to maximize revenue? So we found that the maximum revenue is obtained if we sold 150 units. This is the price. So we just replace X with 150 and we will be able to solve for that price. So letter E, at X equals 150, P will be negative 1/3 times 150 plus 100. So if you solve this, this is $50. Okay? Questions? So a farmer with 2,000 meters of fencing wants to enclose a rectangular plot that borders on a straight highway. If the farmer does not fence the side along the highway, what is the largest area that can be enclosed? So let us try to visualize the situation. So there's a highway. This is, say, your highway. Okay. And then you have the farmer and wants to enclose rectangular plot such that the side that runs just beside the highway is not included. Okay? So if the farmer does not fence the side along the highway, so this guy here. Okay? So suppose this is the rectangular plot. So the rectangular plot is this guy. So the question is, what is the largest area that can be enclosed? So let's introduce our variables. So let X be the length of the rectangular plot and then let Y be the width, of the rectangular plot. So if we look at the sketch here, this will be our x, and this will be our y. And of course, this is also y. Okay? Now, according to this, the perimeter without this side here, okay? So the length of the fencing material is 2,000 meters. Therefore, if you add y, x, and y here, you should get 2,000 meters. Okay? So then, we have x plus 2y. This is equal to 2,000 meters. So the question is, what is the largest area that can be exposed? So this is your area, and you want to maximize this largest area here. Okay? So what we're going to do is to set up a quadratic model that will give us the area of this rectangular plot. So let A be the area, of the plot. Then this area A is equal to x times y. Correct? So let us label this guy here as our equation 1. And then we label this as our equation 2. Now, we have two variables here, x and y. So what we're going to do is to eliminate one of the variables. Okay? And to do that, what we're going to do is to write one variable in terms of the other, and then substitute that into this equation number 2. So that this a here will just be a function in terms of one variable. Okay? So from here, we can easily isolate the x. Okay? So in equation 1, one can write x equals 2,000 minus 2y. So, since we can write x equals 2,000 minus 2y, we can now write a as a function of only one variable. We replace the x here by this y, by this 2,000 minus 2y. Okay? And therefore, you will have something in y times y. So your a is just in terms of one variable. Okay? So a will become 2,000 minus 2y times y. Okay? Or this guy here, okay? This guy here, we can write it as 2,000 y minus 2y squared. So this is a quadratic function in the variable y. Okay? So look at this. We want to find the largest area. And this will give us the area. So the question is, can we have a largest area? If the model, if the quadratic model of that area is given by this. Okay? Now, observe. The coefficient of your term y squared is a negative number. Correct? Which means that the graph of this function is opening downwards. And furthermore, it will have a highest point. Okay? Which means we can have the largest area. So observe the graph, observe that the graph of A of y, okay, opens downwards, okay, and therefore has a highest point. Has a highest point. So area has a maximum value. So area or A has a maximum value. Okay. It occurs. So it occurs at, remember, negative b over 2a. Okay. It occurs at negative b over 2a. Negative b, you have here, take note, this guy here, let me just rewrite this. This guy here, it's negative 2y squared plus 2000 y. So this guy here, this is your A, this is your B. Okay? So negative B over 2A, the negative B, you have now negative of 2000 all over 2 times A, which is negative 2. And notice, you will have here negative 2000 over negative 4. And this is equal to 500. Correct?
Yes.
Thank you. So, the maximum value of A occurs when your Y equals 500. And we want now the largest area. So we want the actual value of A. Okay? Therefore, if Y, this is equal to your 500, then X equals. So you look at this, you will have 2000 minus 2 times 500, but this is just 1000. 2 times 500, that's 1000. So 2000 minus 1000, that's 1000. So you have your X 500, you have your Y, you have your Y 500, you have your X 1000. The maximum area will be 500 times 1000. Finally, let me just write it here. Finally, the largest area is A equals 1000 times 500. So this is 500,000 square meters. Take note of that unit. So meters squared. And that's our final answer.
Okay.
Thank you. Any questions?
When it comes to A and B,
Yeah.
you always put in the order of
Yes, the A always is the coefficient of your y squared or your squared term. The B is always the coefficient of the linear term. And of course, the C is the constant term. It will always be like that. So for example, you have your f of C. This is A C squared plus B C plus C. Sorry, this is a Greek letter here, C, Xi.
okay.
So anyway, so that's always the case. The squared term, it will always be the A as the coefficient. The linear term, it's always the B. Okay, and then the constant term, it's just your letter C. So that's why we wrote it this way, so you will remember it properly. This is the squared term, so this is your A. This is the linear term, this is your B. For our last example for this section, a projectile is fired at an inclination of 45 degrees to the horizontal with a muzzle velocity of 100 feet per second. The height h of the projectile is modeled by this equation. So h of x equals negative 32 over 100 squared x squared plus x, where x is the horizontal distance of the projectile from the firing point. So if you remember from the previous examples, this is the same form of the equation. You have 32 in the numerator, the denominator is something squared, and of course you have the negative in front. That's the coefficient of your squared term, okay? So this formula is well known. This kind of form, okay, for this type of problem, projectile problem to be more accurate, it's a well known, okay? So for the part A, at what horizontal distance from the firing point is the height of the projectile maximum? Okay, so let's look at that. Let's look at the situation. So suppose this is your ground, and then suppose this is your firing point. Okay, let us assume that this is a particle on that ground. So we will assume that its position, okay, when the projectile is released, it's coming from the ground, and therefore the height at that position is 0. So the projectile will be coming exactly from the ground. Okay, and once this is fired, it will create a projectile motion that goes something like this. Okay, so at the end you will have the projectile at this position, and according to this equation the projectile will be quadratic, so it will have this kind of graph. The graph of a quadratic function, it's a parabola. So this is a parabola. So the graph will be parabolic here. So the question is, at what horizontal distance from the firing point is the height of the projectile a maximum? This is the maximum height. Okay, this is the maximum height, assuming that the vertex is at this point. So you are asked to find the value of x in here. That's for letter A. At what horizontal distance? So from here up to this. So this is x units. And this is what we want to find. Okay? If we only look at this as some graph of a parabola, then this guy here, this particular point here, will have coordinates x, comma, h of x. Now, to reduce the confusion here, instead of just writing x in here, let me write x sub 0, a particular value of x. Okay? So, therefore, this point here has coordinates x sub 0, h of x sub 0. So, we need this x sub 0 in here. But this is the vertex. And again, what is the x coordinate of the vertex? It's just your negative b over 2a. Correct? So, to answer A, okay, to answer A, the horizontal distance from the firing point, from the firing point with the maximum height, for which the projectile is at the highest point. So the horizontal distance from the firing point, for which the projectile is at the highest point is, so again, this is your A here, this is the B here. I mean the coefficient here, which is just 1. So this is negative B over 2A. So this is negative 32 over 100 squared all over 2 times, sorry, you have negative of negative because you have that negative there. Negative of negative. And then all over 2 times A, which is just 1. So negative of the negative, it becomes positive. And then you just have the 2 here. So this is equal to 32 over. Sorry, what am I writing? This is your A. We need it on the denominator. Okay? So my apologies. So you have here negative 1, that's your B, all over 2 times A. And this is your negative 32 over 100 squared. Okay? And therefore, this is just what? You have the negative and negative here, it becomes positive. And then this 100 squared, it's on the denominator of the big denominator here. So it can go up to the numerator so that you will get 100 squared over 64. Okay? And we can simplify this. But when you simplify, be sure to write it in fraction form. Okay, so you have 100 squared, that's 10,000 divided by 64. Okay, so you have 156.25. So in fraction form with the lowest term, you will have 600 um, 624 or 25 over 4. Correct? So you have this. So this is the horizontal distance for which the projectile is at the highest point. Okay? And of course, I know that some of you will still write this in decimal point. So let me write it anyway. Okay? So that's for letter A. For letter B, what's the maximum height? You got your x sub 0. All we need to do is to evaluate that x sub 0. Okay? So for letter B, the maximum height is so you have h of 625 over 4. Okay, 625 over 4. So this will be equal to negative 32 over 100 squared times this guy here squared. So 625 over 4 squared. And then plus the x here. So it's again 625 over 4. And then you just simplify this. So let's try to simplify this. This is equal to 625 over 4. So I'm going to factor 625 over 4. So I will be left here with 32 over 100 squared, yeah, times 625 over 4, and then you have the plus 1 there. Okay? And then try to simplify this. I will need the next page. So here, let us simplify this. So equals that. 32 over 4. So 32 over 4, that's 8. Correct? 32 over 4, that's 8. So you will just have 8 times 625. So 8 times 625. So in here, you have 625 over 4 times negative 5,000 divided by 1,000 here, or 10,000 here. 100 squared, that's 10,000. Numerator, it's 5,000. So this guy here is just 1/2. Then you have your plus 1 here. So simplifying, this is just 1/2. So negative 1/2 plus 1, that's 1/2. So 625 over 4 times 1/2. You will have 625 over 8.
What happened to the 625?
So you
Over-
got
yeah.
here 32 over 4, that's 8.
Oh,
So
you
this
crossed.
guy,
Oh,
this
you
is-
did. You crossed.
I canceled.
Okay.
So I canceled it. Okay? Because this is
Okay.
just multiplication, so I can cancel that. So 8 times 6 to 5 over this guy here.
But you cancel. You cancel.
8 and 4.
Cancel in X.
Sorry?
You cancel like crossing, like X, right? Like X. The way you cancel.
Yes, the cancellation law. If you
Okay.
have if you have something like A over B times C over A, then this
Mhm.
guy will cancel. So this
Ah,
is
okay, I
just
see.
C over B. The cancellation law.
Okay. So the okay, so the 100 squared, you don't multiply by 625.
No,
Okay.
no. It remains on the denominator because numerator times numerator, denominator times denominator.
Okay. Thank you.
You're welcome. So you have this 625 over 8. Okay? So this is the maximum height. Okay?
Okay, so
let's try
we cannot really simplify or anything.
yeah,
So we just leave it like that.
leave
Okay.
it like that. Okay? And then for letter C, at what horizontal distance from the firing point will the projectile strike the ground? So if we go back to our illustration here, so from here it will rise and then fall, and eventually you will reach the projectile will reach the ground. So for letter C, the question is, what is this distance? Okay, so this guy here from this point to this point. Let me just write this as x sub f, the final distance. And what do we mean by that? The height is equal to 0 because it's on the ground. So we need to find x for which h of x equals 0. So find x. So need to find x for which h of x equals 0. So h of x is this guy here, negative 32 over 100 squared, x squared plus x, this is equal to 0. You can factor out x, and you will get x times negative 32 over 100 squared x plus 1 equals 0. So either you have x equals 0, that's actually your starting point, or you got here negative 32 over 100 squared x plus 1 equals 0. Okay? And so the final point is, or the final ground point, okay? The final ground point is this case. So if you solve for this, you put this guy here on the other side, and then you solve for x, you will get x sub f equals 100 squared over 32 feet. And you can simplify this. You can reduce this to lowest term. Okay? So let me just reduce that to lowest term. So 100 squared over 32. That's just 625 over 2. So 625 over 2